Okay, so starting chapter 4 review, which is the last chapter that the first semester covers, we started talking about systems of equations, and we talked about several different ways, 3 different ways to solve systems of equations. Then we talked about systems of inequalities. But just starting with systems of equations, the first method they gave us was graphing. And when we graph, there are several different outcomes we could have. We can find an exact solution. We might be able to see exactly where the 2 lines cross. We could come up with an approximate solution, it crosses about here. We can kind of estimate. We can have a situation where there's no solution. The lines never cross. Remember, if you have parallel lines, so different y-intercept but same slope, they're never going to cross. They're never going to cross. I should enunciate. They're never going to cross, and so there would be no solution. If it's the same line, if it has the same slope and the same y-intercept, then there's infinite solutions. It doesn't matter what the x value is, it's going to be the same. And there could be one solution, and that's where they just cross at one point. So we're going to start with this one. Go ahead and try it out, and then compare and see. We have y equals 3x minus 1, and y equals negative 2x plus 3. And so we're going to solve that using graphing. So I'm going to go ahead and graph this first one, y equals 3x minus 1. So we're going to start at negative 1. So I have a point right here. And my slope is 3. So that means I rise 3 and run 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And I should get the ruler out and sketch that. Did I do that right? 1, 2, 3 over 1. Yeah. Okay, so I'll do that later. Now I'm going to do this one, negative 2x plus 3. So that one starts at positive 3. And it has a slope of negative 2. So my rise is actually a fall. So I fall 2 and go over 1. Fall 2 and go over 1. Forgot to go over 1. Go over 1. Fall 2 and go over 1. Okay, so that's what that one's going to look like. I probably should have used a different color so that didn't look so confusing. Okay, so I'm going to get out my handy-dandy ruler and draw in my 2 lines. Try not to mess that up. Okay, so I'm drawing my line. So that's line 1. Use a different color for line 2. Okay, and draw that in. And where my 2 lines cross is my point where it's true for both. So if I put my point right there, this is where we would have what you would call an approximate solution. Okay, because that, I don't know what that is. We could say x is probably, that's pretty close. We'll say 0.8 for my x. And what would my y be? Y would be 1, I don't know, 1.5? Yeah, let's call that. That's pretty close to 1 point. It's pretty close to half. Well, say 1.4. I would make it 1.45, 1.49. Anyway, so, and that would be an approximate solution, right, that we get from graphing it, because it doesn't land directly on a point, and so we can't necessarily tell what it would be from graphing it. Luckily, so we would say the solution is approximately 0.8, 1.4. Okay, because this is a review, I know you guys already know different ways of doing this. You could do substitution, you could do elimination. Because we have y equals 3x minus 1 and y equals negative 2x plus 3, I'm going to use substitution because it's already solved for y. So I'm just going to replace this y with this right here, and I have 3x minus 1 is equal to negative 2x plus 3. And then I'm going to add 2x to both sides because I want my x's on one side and my numbers on another side. 3x plus 2x gives me 5x. Minus 1 is still there. That has canceled, and I have a 3. Add 1 to both sides, and we get 5x equals 4, which means if we divide both sides by 5, x equals 4 over 5, which is actually 0.8. I may or may not have actually looked at the book to get that. I didn't look for the y, though. Okay, so 0.8 is our x value. And then once we have that, we can plug that back in for x and get our y value. So let's do that. Y equals 3 times 0.8 minus 1. 3 times 0.8 would give me 2.4, right? Because 8 times 3 is 24, but it's a 0.8, so 2.4 minus 1, which means, hey, that's pretty good. Y would equal 1.4. I guessed on that. I mean, I estimated. I went for 1.4, but that means that we were actually exactly right. It's not approximately, it's exactly 0.8 and 1.4. Okay, so graphing is one way we can do this, and then we used substitution as well. All right, I think that'll be it for this video.